Hurricanes are one of nature's most destructive forces, killing thousands of people every year, all over the planet.
A single storm going into Bangladesh not many years ago killed almost 500,000 people. That's a lot of people. It's a colossal, horrible thing. Even in this country, we've seen Katrina take the lives of somewhat over 1,500 people.
And scientists predict that because of the effects of global warming, there is much worse to come.
As the ocean temperatures warm up, we now have more energy available for these hurricanes to develop. So where a hurricane might have been a Category 5, in current climate, maybe we have to invent a Category 6.
It's not just a problem for the United States. China, India, Japan, and many other countries are vulnerable to these storms. And as the storms get bigger and the death tolls mount, there will be increasing pressure to act. A radical idea from the 1950s, long discarded, is once more being taken seriously. The idea of hurricane modification, finding ways to weaken or deflect a hurricane before it hits shore.
I think that the technical barriers are not nearly as large as the social and political barriers, because we rightly don't easily want to tamper with Mother Nature.
In fact, much of the technology may already exist.
We've done simulations with Hurricane Katrina, and we still had the strong winds, we still had the deep cloud systems, the rainfall. However, what was a little bit surprising is that there seemed to be a few degrees change in the path of the hurricane.
Just how close are scientists to controlling superstorms? And what are the risks of playing God with the weather? The coastline of the United States is frequently battered by hurricanes. Perched right on the tip of Florida, Miami is one of the East Coast's most vulnerable cities.
How's the thing look near Africa?
Dr. Chris Lancy is a meteorologist in Miami's National Hurricane Center. He has experienced the devastating force of hurricanes at first hand.
The biggest personal interaction I've had with a hurricane was Hurricane Andrew in 1992. I was actually studying hurricanes for graduate school when Hurricane Andrew hit Miami and my home.
The hurricane hit Florida's east coast at 5 a.m., with winds gusting up to a terrifying 160 miles an hour.
I came down after the hurricane to see what had happened and to help clean up. And I was just shocked to see that my neighborhood, my area, was essentially bombed out.
I wouldn't believe that wind alone could do that.
20 miles south of Miami, and this is all that remains of a low-rise housing estate.
All the trees, a large majority of the houses had either partial or full damage. A portion of my parents' house, the roof, a third of the roof had been lifted up by the winds and carried about 2 blocks away. It was an eye-opening experience for me because in the past, hurricanes had just been something I studied in school. And yet here was one that directly impacted my family. I was very fortunate that no one had been hurt or killed. Still to this day, Hurricane Andrew's impact is felt by many people.
To understand why the US coastline is so vulnerable to hurricane strike, you have to travel over 4,000 miles east to the place where hurricanes are born. Most hurricanes in the Atlantic begin as very small atmospheric disturbances in the jet stream that flows from east to west over sub-Saharan Africa. Scientists call this disturbance an easterly wave.
What triggers the development of an easterly wave could be anything. Could be a little girl playing in the sand. It trigger off a little dust devil, for example, that perturbs the atmosphere downstream in such a way that you get one of these waves.
The easterly wave creates a system of turbulent eddies, which go on to develop into a cluster of thunderstorms. These travel west across the African continent and then encounter the warm tropical waters of the Atlantic.
One begins to see on satellite pictures is these thunderstorms appear to become better organized and begin to rotate around each other. The rotation rate increases, the storms become more vigorous, and the winds continue to increase.
The storm rapidly gathers strength and develops into a hurricane, feeding off the warm, moist air coming from the ocean.
The heat is coming out of the ocean. The hurricane heat engine converts that heat energy into the mechanical energy of the winds. And that's what's powering the storm. When the winds reach typically around 70 miles per hour, the storm may develop an eye, surrounded by an eye wall, which is a region of very intense heat and the strongest winds. And you're off and running.
These are the hurricanes that make landfall on the US every year, causing enormous damage. The disturbing thing is, a new trend in hurricane behavior has recently emerged, which scientists believe is linked to global warming. Professor Greg Holland is a leading authority on hurricanes who's been investigating these claims.
Some statements have been made by other scientists on the effects of global warming, and we decided to just go back and look at the entire record of hurricanes around the world going back to 1970.
He collected data from hurricanes in the Atlantic, typhoons in the Pacific, and tropical cyclones in the Indian Ocean. He analyzed the frequency and intensity of these storms over a 30-year period to see if he could detect any noticeable change in their behavior. What he discovered was both controversial and shocking.
We found that over the last 30 years, the proportion of Category 4 and 5 hurricanes had nearly doubled. The increase in the Category 4 and 5 hurricanes is consistent with global climate change because as the ocean temperatures warm up, we now have more energy available for these hurricanes to develop. And that means that hurricanes are going to be meaner, more intense, doing more damage. Where a hurricane might have been a Category 5 in current climate, maybe we have to invent a Category 6.
NOAA is predicting an above normal hurricane season with 13 to 16 named storms, of which 8 to 10 are predicted to become hurricanes, and 4 to 6 of those hurricanes are predicted to become...
This worrying trend has led people to ask whether anything can be done.
One question that comes up all the time is, why can't we just get rid of hurricanes? You know, we're so smart, you know, can't we figure out a way to steer it the other way or get rid of it completely?
Theories on how to combat hurricanes are constantly put forward by well-meaning people to staff at the National Hurricane Center.
We often get ideas, for example, let's tow icebergs from the Arctic, cool the waters down. The idea of towing the icebergs is sound physically, If you do cool the ocean temperatures by 5 or 10 degrees, you would weaken the hurricanes. But the practicality is that you would need all of the large ships in the whole world to constantly be towing icebergs down to have enough cooling effect to really have an insurance that hurricanes would be weaker. Another idea, let's hit the hurricane with a nuclear bomb. But that doesn't take into account that each hurricane produces the same amount of energy, if not more, than all of the electrical generation capacity of the whole Earth. So if you toss a nuclear bomb in, it would have no impact. And then the problem would be you'd have a radioactive hurricane moving ashore. I don't think that's something anybody would want.
Not all ideas are so far-fetched, however. One of the world's most respected hurricane physicists, Professor Kerry Emanuel of MIT, believes the answer may lie in copying nature.
The idea begins from an observation that many hurricanes are steered harmlessly out to sea before they ever hit land. And that happens because of an accident of the weather, if you will. There are constantly weather systems forming and developing and moving across the country, giving us what we know as weather. And if one of those weather systems happen to be coming along when a hurricane's approaching the state, that weather system will interact with the hurricane in such a way as to steer it offshore.
This process was captured by a NASA satellite in 2005, when Hurricane Ophelia was whipped back out to sea by a weather system moving in from the northwest. So would it be possible to artificially create a weather system capable of deflecting a hurricane? Professor Emanuel thinks it could be done by harnessing the science which governs the atmosphere. Chaos theory.
It's a bit hard for people to grasp how sensitive the atmosphere is. Ed Lorenz, who is widely regarded as the father of chaos theory, illustrated it with the notion that a butterfly flapping its wings in Peru might several weeks later lead to a tornado in Texas. It's very, very hard for people to realize that this is not a metaphor. It's really true.
The atmosphere is a perfect example of a chaotic system. This means that very small disturbances made in one place set in motion a chain of events that can result in very large-scale changes in the weather somewhere else.
So the notion then becomes, can you tame that butterfly? Can you introduce a butterfly just the right place at just the right time to have a desired effect? Well, here's a plausible scenario. The first step is that you run a large computer program, and it tells you that if the hurricane now approaching Miami is to avoid Miami, you need to seed the atmosphere somewhere over the eastern Pacific Ocean west of the United States. So then you would send out a fleet of aircraft, specially designed aircraft, which would put out a set of contrails of, let's say, fine black carbon dust, environmentally safe, in a sheet that slopes westward with height. That sheet, which might be 1,000 miles long, but not very wide, would subsequently absorb sunlight and introduce a very small temperature perturbation, a 0.5 degree temperature perturbation.
If you scatter carbon dust into the sky, it will, being black, absorb sunlight and slightly warm the air. If done correctly, this small temperature change, or perturbation, can lead to large-scale effects.
The atmosphere would naturally amplify this temperature perturbation, and as it moves toward the east over the US, the system would cause a normal kind of weather system, a low pressure area that we have all the time, but this sort of now happening where and when we want it to. And 3 days later, it begins to interact with our hurricane and steers the hurricane offshore. so that it never hits land. That's a actually plausible scenario.
This idea, although promising, has yet to be tested in the real world. There is, however, another approach to hurricane modification that was first tested back in the 1960s, following a series of devastating storms.
Hurricane Agnes takes 134 lives.
If only the force of the hurricane's winds could be reduced, the toll in death and damage could be greatly lessened. Is there a way? Project Storm Fury, a joint effort of NOAA, the Navy, and the Air Force, is designed to try to find one.
The time that Storm Fury began was at a period of optimism in how we could beneficially control the weather.
Scientists working on the project were convinced that they could reduce hurricane devastation using a process called cloud seeding, by spraying the thunderclouds inside the hurricane with a chemical called silver iodide. This would become known as the Storm Fury hypothesis.
Seen from directly above, the center of the hurricane is called the eye. The dense ring of clouds around the center is the eye wall, where large masses of warm, moisture-laden air rise from near sea level to great heights. Water vapor condenses in vast quantities. Some of the condensed droplets are carried aloft where temperatures are below freezing, but continue to exist as supercooled droplets. The seeding planes fly across the eye and into these clouds, seeding the supercooled water droplets from the belt of maximum winds outwards. The silver iodide acts to transform the supercooled water droplets into ice crystals, upsetting the delicate heat balance of the storm.
As the silver iodide turns the supercooled water into ice, the heat released during this process causes the seeded clouds to grow and develop into a new outer eye wall.
And the idea was that outer one would contract in and essentially squeeze off or strangulate the inner one. And as it does that, the hurricane weakens. So the theory is right. If you can make the outer part a little stronger, you make the very dangerous inner core, the eye wall, that's weaker.
They had their theory. Now all they had to do was put it into practice. In August 1969, Hurricane Debbie was born off the west coast of Africa. It was the perfect storm to test their ideas on. Dr. Robert Sheets was one of the scientists who took part in this remarkable experiment.
And we're all nervous. I mean, I don't care, anybody that was on that flight was nervous before we ever got there, because we knew we were going to do something very dangerous, pushing the airplane to its limits.
On the 18th of August, the scientists left Puerto Rico Air Base to meet Hurricane Debbie. The plane was heading towards the eye wall, the most dangerous part of the hurricane, where winds can reach an incredible 180 miles per hour.
You could see it on the radar there. You're watching the instruments, watching the radar. I just sort of kept waiting, you know, what's going to happen here? And I'm holding on my seat, when's it going to hit? When's it going to hit? And then all of a sudden, shoot.
Looks good. Think we got the center.
Once inside the eye wall, Bob Sheets' job was to measure wind speeds before, during, and after seeding.
We flew back and forth through the core of the hurricane in a figure 4 fashion. We measured that the wind speeds, maximum sustained wind speeds, are about 115 miles per hour. We then start seeding, and continually monitor the storm throughout this period and for the next few hours after the seeding had ended.
Robert and the team were astonished by what happened next.
And the end result was that the wind speed was now down below 100 miles per hour.
The seeding appeared to have worked. To be sure of this, the scientists repeated the experiment to see if they could replicate these results.
Now we leave the storm alone for the next 24 hours. It now regains the strength. The eye wall gets better defined than it was on the first day, as a matter of fact. It's now back up to 115 miles per hour maximum sustained winds.
They seeded the clouds once more and again witnessed a fall in wind speeds inside the hurricane.
And by the end of that experiment, it's down to about 100 miles per hour. This reduction doesn't sound like much, but if you can take a Category 3 hurricane and make it into a Category 2 hurricane, there's a tremendous difference in the damage that's done, even though the wind speed has only been reduced 10 or 15 miles per hour.
So impressive were the results from Hurricane Debbie that many scientists recommended that in future, every hurricane likely to hit the coast should be seeded.
They even went so far to say that if the government does not seed a hurricane with this technology you've developed here, if they do not seed a hurricane making landfall, then you ought to be liable for the damage that it's done.
The US government quickly allocated $30 million to further their research. But ironically, what they were to find would spell the end for Project Storm Fury.
Fire 3. Fire 4.
Flying again and again into storms, they discovered something no one had suspected. Eye wall replacement can occur quite naturally in hurricanes. It was impossible to prove whether seeding triggered eye wall replacement or whether it happened naturally. Project Storm Fury was brought to a close in 1982. The technology available at the time was simply not sophisticated enough to prove whether seeding made hurricanes weaker, stronger, or had any effect at all. In the last 30 years, all of this has changed. Computers, satellites, and new instruments on board aircraft have transformed our understanding of hurricanes.
We have aircraft fly right into the middle of the storm. They actually go right through the storm, usually about 10,000 feet above the ocean. And it launches instruments, we call them dropsondes, out of the belly of the aircraft to measure the entire atmosphere, the winds, the pressure, and humidity. And that sends that information back to our headquarters, and that gets into the computer models.
The detailed information provided by these computer models has made hurricane forecasting more accurate than ever before. Dr. Rolf Brunches from the National Center for Atmospheric Research is putting this information to a very different use. He's breathing life back into the science of cloud seeding.
Yeah, if you can see what the distance is, that would be helpful.
We've seen great developments in computer technology. We can put more of our physics into numerical models. We've seen great developments in terms of remote sensing, radars, satellites, that now provide us the opportunity for the first time to really look inside clouds, being able to see what kind of ice crystals, what kind of droplets there are in clouds. So these measurement capabilities give us now for the first time the opportunity to explain, if we get a statistical result, why it doesn't work or why it does work, and then quantify those results.
We asked Dr. Brunjes to re-examine the work of Project Storm Fury and test its hypothesis on a computer simulation of Hurricane Katrina.
After Hurricane Katrina, we had many requests, well, can we modify hurricanes? And usually when big hurricanes strike, these are the kind of requests from media, from all different kinds of people that you get. And so we thought we can do better than people could do during Storm Fury. So we just thought, well, let's go back to the original concept, conducting the seeding with silver iodide. So we decided just to do one very rudimentary run and freeze all the supercooled water at a certain stage and see what would happen to the hurricane.
Using a detailed model of Katrina, he was able to identify the regions that contained high concentrations of supercooled water and simulate the cloud seeding process in these areas.
The area in red here is the supercooled liquid water content. So what we do in a seeding simulation, we freeze all this water, turn this into ice crystals. So as you can see in the seeded simulation over here, we don't see any more supercooled liquid water content. This is all turned into ice crystals.
This transformation could, in theory, weaken the hurricane's strength. Dr. Brungies was skeptical that this would make any difference to the behavior of the hurricane. But it did.
Actually very surprising. It didn't seem to change anything in the intensity of the hurricane. We still had the strong winds, we still had the deep cloud systems, the rainfall. However, what was a little bit surprising is that there seemed to be a few degrees change in the path of the hurricane.
A few degrees doesn't sound like much, but in the case of Katrina, it would have meant that the hurricane would have been diverted 50 kilometers from its original path, producing a very different outcome. If this is the case, what is stopping scientists from testing seeding on a real hurricane? Could hurricane modification, one day, become a reality?
In the computer, we can do some tweaking. We can make it a little warmer, a little colder, make the winds a little stronger or weaker. If theoretically you could do such a tweak, and you could change the course of the hurricane or make it a little weaker. But if you don't get the tweak exactly right, do we know what's going to happen? And I don't think we really do.
If we really wanted to do it, if we said, we're going to do this the way we said we're going to put a man on the moon, I don't think it would take very many years to come up with the technology. I think that the technical barriers are not nearly as large as the social and political barriers, because we rightly don't easily want to tamper with Mother Nature.
In the next program, we explore the moral and ethical implications of weather modification through its controversial and checkered history, and ask the question, should we be playing God with the weather?
And that's at the same time next week. And if you missed BBC One's drama Superstorm tonight, you can watch it again here on BBC Two next Saturday at 6. Coming up, who's on their way to Wembley? The best of the day's football with Match of the Day 2.
Global warming is forecast to have a catastrophic effect on weather all over the planet. And this will place extreme pressure on the world's natural resources.
If our predictions are correct, by the year 2025, water will really become the most critical issue for human survival.
To try and combat these effects, experts are increasingly turning to weather modification techniques, such as cloud seeding.
We can make a change within cloud systems to produce more rain for drinking water, for agriculture. That makes a tremendous difference.
In the future, weather modification could even be used to tackle the growing threat of superstorms.
We might be able to prevent or reduce vulnerability to serious hurricanes by controlling the storm, by reducing its intensity, by steering it out to sea. I don't think it would take very many years to come up with the technology.
But while there are clear humanitarian reasons for wanting to manipulate the weather, there is also a dark history behind previous attempts to do so. The British, Russian, and American governments have all conducted top-secret weather modification projects. sometimes with disastrous consequences.
Military planners imagined loading the clouds with radiological, biological, or chemical agents and having them rain on demand. We had opened this Pandora's box of evil, and we really didn't know where it would lead us to.
For the first time, some of those actively involved have agreed to talk.
The area where my crew was actively influencing the clouds was near Chernobyl.
In this program, we investigate the potential benefits and the appalling consequences of attempting to control the weather. Dr. Rolf Brunjes is one of the world's leading authorities on weather modification. He's been conducting research in this area for more than 20 years.
Flying an aircraft between clouds, you feel very small, and trying to explore and trying to understand what is happening inside clouds is one of the greatest challenges.
Dr. Brunjes' expertise is in demand all over the world for one very good reason. He can make it rain. A rapidly growing population coupled with global warming means that water is increasingly set to become the world's most precious commodity. One of the solutions to this problem can be found within clouds.
An average rain cloud contains about 8 million tons of rainwater, and therefore there's a vast quantity of untapped fresh water in the sky, and this is where cloud seeding comes in, to address the growing needs for water around the world.
Most rainmaking techniques used today originated back in 1946, when scientists discovered that by dropping particles of a chemical called silver iodide into cloud tops, they could trigger rainfall. Since then, countries all over the world have experimented with different ways to squeeze rain out of the clouds. China spends more on cloud seeding than any other country in the world.
I'll put the radar on here in the aircraft so you can find the distance to that cell band. Yeah, if you can see what the distance is, that would be
Dr. Brunjes is in Mali, West Africa, to test out a new technique he's devised with colleagues at the National Center for Atmospheric Research. It involves the use of pyrotechnic flares to deliver a special seeding material into the base of a cloud.
These are the so-called hygroscopic flares. They consist of salts inside. And as we burn them, the smoke produces the particles, the salt particles, that will then be taken up into the cloud and participate in the rain formation.
Once released into the cloud's updraft, each one of the hygroscopic salt particles becomes a seed around which a single water droplet can form. These droplets collide with each other and grow, eventually becoming heavy enough to fall out of the cloud as rain.
Oh, there's a rainbow up front here.
Weather modification today is an increasingly precise science which can reap huge benefits for the many countries that suffer from severe water shortages.
In the last few years, we've literally been on all 5 continents. A lot of our work focused on Southeast Asia, Africa, North and South America, and then also in Europe, Italy and Greece. There are currently more than 47 countries, more than 150 programs, cloud seeding programs, going on as we speak.
Ron, you can go back.
Cloud seeding seems to be making a change for the better for many people in the world today. But it's a science that is born out of a murky and troubled past.
Tragedy, sudden and appalling, descends upon the little seaside resort of Lynmouth.
In 1952, a freak storm destroyed a sleepy Devonshire village.
This was the main street of Lynmouth only a few days ago.
The storm led to catastrophic flooding that destroyed the town and killed 35 people. It was the most destructive storm in British history. But was it a natural one? Within days of the catastrophe, there were rumours of secret experiments. Rumours which the Met Office and the Ministry of Defence flatly denied. Then a witness came forward. A glider pilot, Alan Yates, now deceased, told a BBC journalist that just prior to the Lynmouth flood, he had taken part in a government-sponsored cloud seeding experiment.
We'd assembled at Cranfield in Bedfordshire in mid-August 1952, studying clouds. On the day I'm recalling, the weather was superb, but the cotton wool cumulus clouds were growing everywhere, and it was decided to make them rain.
Yates told the journalist that he and his colleagues had seeded clouds over the Bedfordshire countryside and had witnessed the effects for themselves.
I circled down between the clouds, still doggedly noting temperature, height, time, and the rest. Eventually, far below, I saw a sodden-looking countryside. Toasts were drunk to meteorology. They'd certainly made it rain.
Recently declassified documents have confirmed that the experiment, codename Operation Cumulus, took place in the first 2 weeks of August and coincided with the heaviest rainfall in Bedfordshire for many years. The experiment was heralded as a resounding success, until the rain continued to spread west, across the country, and into Devon. More than 50 years after the event, it is impossible to say if cloud seeding really did trigger the most destructive storm in British history, or if it was just an unfortunate coincidence. What is clear is that the government, anxious not to be blamed, closed the project down and denied it had ever taken place. A decade after the Lynmouth disaster, research on cloud seeding was to continue, this time in the United States, with Project Storm Fury.
Project Storm Fury assembles a team of highly trained scientists and technicians to fly into mature hurricanes.
They were hoping to use the technology to weaken hurricanes. What the Storm Fury scientists didn't realize, however, was that their research had caught the eye of the military. Dr. Joanne Simpson was one of the pioneers of Project Storm Fury. She was to find out only much later that the military were developing her techniques and using them as a weapon of war.
I thought it was terrible. I mean, all my life I've tried to work for the betterment of the planet and the people, even in a small way, and then to use what I've done as some kind of a military thing, I obviously am very concerned and not happy about it.
At that time, the United States Army were in Vietnam, struggling against the Viet Cong, an elusive guerrilla army. The Pentagon were desperate to explore anything that might give them an edge. So when military planners suggested that cloud seeding might trigger massive downpours and flood the Viet Cong's main supply routes, the government were quick to respond. Pierre Saint-Amand was part of the team assembled in a top-secret cloud seeding operation known simply as Project Popeye.
The main purpose of Project Popeye was to demonstrate that cloud seeding would actually increase the rainfall on the Ho Chi Minh Trail. So by making the trail more muddy and trafficability difficult, we were hoping to keep people out of the fight.
The Ho Chi Minh Trail was of key strategic importance to the Viet Cong, the route along which vital weapons and supplies were transported. In May 1967, as monsoon clouds developed over the Ho Chi Minh Trail, Armand and his team put their new weapon to the test.
We had 2 Cedar aircraft, and then we usually had a Marine fighter pilot laying alongside of us to keep the bad guys from shooting us down. We ejected the material so that it fell into the growing part of the cloud.
The results were spectacular.
The first one we seeded grew like an atomic bomb explosion, and it rained very heavily out of it, and everybody was convinced with that one experiment that we'd had done enough.
Having witnessed the success of this experiment, the military now began to dream of more radical and extreme uses to which the technology could be applied.
Imagine a weapon that could affect the entire planet, and yet you could launch an attack against an enemy and they wouldn't even know it. Military planners imagined loading the clouds with radiological, biological, or chemical agents and having them rain on demand. Some said, if you control the weather, you can control the world.
The belief was that you could attack your enemy using the weather, but deny ever doing so. Experiments in Vietnam continued for 5 years until in 1972, a leak from the White House blew the cover on Project Popeye. Allegations were made that cloud seeding had not only made jungle paths impassable, it had also killed thousands of innocent people.
When Project Popeye was revealed in the press, it caused an immediate firestorm of criticism. People were concerned at the time that we had opened this Pandora's box of evil, and we really didn't know where it would lead us to.
Project Popeye had opened the door to a new and dangerous type of warfare. The firestorm it created led to an international treaty banning all use of weather modification for military purposes. But this didn't stop governments from continuing to explore ways of modifying the weather, sometimes for highly questionable purposes. For decades, the Soviet Union seeded clouds before they reached Moscow in order to prevent rainfall on their big military parades. Harmless enough? But evidence has recently come to light that the Soviet authorities also used this technology for something much more sinister. the effects of which are still being felt today. April 1986, the Chernobyl nuclear power plant in Ukraine exploded, spewing hundreds of tons of radioactive material into the atmosphere and creating the most horrific nuclear disaster in history. In 1992, Dr. Alan Flowers was one of the first Western scientists allowed into the area to examine the extent of the radioactive fallout around Chernobyl. He was working in Gomel, in the Republic of Belarus, in a region that lies between Chernobyl and Moscow.
I was with my research group measuring levels of radioactivity in the soils and also the levels of radiation dose that the population were exposed to. And we found, even 5 years after the Chernobyl accident, the population were still being subjected to levels of dose 20 to 30 times higher than normal environmental radiation levels.
Many children in Belarus were showing the effects of intense radiation poisoning. But how was this possible so far from the reactor?
We would not normally expect, at a distance of 150 to 200 kilometers, such high levels of radioactivity, unless, of course, there had been some very unusual and intense rain.
Following the explosion, there was a buildup of heavily radioactive rain clouds above Chernobyl. The prevailing winds threatened to blow these radioactive clouds towards Russia and the major cities of Moscow and St. Petersburg. But the rain never reached these cities. Instead, bouts of very heavy rain fell on the southeastern corner of Belarus. The same area that Dr. Flowers revealed to be showing unusually high levels of radioactivity. Disturbingly, many eyewitnesses claimed that the rainfall was caused by cloud seeding.
One of our colleagues told us about the Sunday immediately after Chernobyl, when he drove back from the city of Gomel in very heavy rain and noticing aeroplanes in the sky with colored materials coming out and trailing them.
There were eyewitnesses that saw the planes. And after the planes had passed, the black rainfall started.
Dr. Zion Pazhniak, a Belarusian scientist and politician, is convinced that to save Moscow, the Soviet authorities deliberately rained out radioactive material on Belarus and openly accused them of doing so. Today, he lives in exile.
I can speak freely about anything I want now, though I know if I ever go back to Belarus, I'll be killed. I know that.
Dr. Pazhniak believes that people in his country were sacrificed to prevent the disaster spreading elsewhere.
They were afraid that the clouds would move to the Russian region, and there would be a possibility of rainfall over Moscow or St. Petersburg. That's why they decided to rain out the clouds on the heads of the people of Belarus.
The Moscow authorities denied that cloud seeding had taken place after the accident. However, last year, at the 20th anniversary of the Chernobyl disaster, among those honored for their bravery was a pilot called Major Alexei Grushin. The award he received was for cloud seeding operations during the Chernobyl cleanup.
I am proud to say that I took part in the operations back in 1986. My comrades are proud as well. The area where my crew was actively influencing the clouds was near Chernobyl, not only in the 30-kilometer zone, but out to a distance of 50, 70, even 100 kilometers. The plane was equipped with artillery shells, which were filled with a seeding material, silver iodide. And we were following orders from the ground regarding which zones we were required to seed. The wind direction was moving from west to east, and the radioactive clouds were threatening to reach the highly populated areas of Moscow, Voronezh, Nizhny Novgorod, and Yaroslavl. If the rain had fallen on those cities, it would have meant a catastrophe for millions.
During this cleanup operation, Major Grushin, his crew, and his plane were heavily exposed to radiation.
Once we landed at the airport, I was ordered to park my plane in a separate place. People came from upwind towards us. They were dressed in anti-radiation outfits and held devices to measure radiation. They reached the plane, and a few seconds later, their devices recorded such high radiation that it made them turn around and run away. The plane was highly contaminated. We were given a place in the airport where nobody was parked, neither planes, no equipment, no people.
The ruins of the Chernobyl power plant stayed highly radioactive for long after the explosion. And Major Grushin said he and others continued to conduct cloud seeding missions months after the blast. Another Russian pilot, who does not wish to be identified, has since confirmed that cloud seeding operations took place as early as 2 days after the explosion. Were the actions of the Soviet authorities justified? Clearly, they faced a terrible dilemma.
You are faced with the fact that a radioactive cloud is there in the sky. That radioactive cloud and the radioactive material in it is going to fall down somewhere. It is going to fall on a human population somewhere. So if you are in Moscow, you have a very difficult decision to make. Do you let nature take its course, and that may then result in this cloud falling on millions and millions of people in Moscow? Or do you intervene? And do you use the technical resources that you have and try to minimize the number of population that this cloud will affect?
The trouble was, the secrecy which surrounded events at Chernobyl meant that the Belarusian people were completely unaware of the coming rain.
The local population talk about how there was absolutely no warning before these heavy rains and the radioactive fallout arrived. Now, if somebody in Moscow knew that there was going to be artificial fallout created in this area, it would have been quite possible to mitigate against that by warning the population to stay indoors, by distributing potassium iodide tablets. It is quite clear that these actions did not take place.
The high levels of radiation found in Belarus have led to dramatic increases in leukemia, thyroid cancers, and child defects.
I had lots of friends in the area where the cloud seeding took place. They had to move away from their homes, and their children became ill. Thyroid cancer has increased amongst children by 50 times in the area where the cloud seeding took place. If there had been no cloud seeding, there would be no radiation. Even if the radiation had reached that far, it would never have been on such a huge scale. They decided to keep the cloud seeding quiet. They thought that the public would never find out about it. Everything would stay a secret and nobody would need to take responsibility.
If you choose to intervene in a weather system, there are immense ethical considerations. One of the moral pitfalls would be trying to stop a disaster from happening in one place, but actually causing a disaster elsewhere. The unintended damage, in other words, may be worse than the kind of damage you're trying to prevent. The weather is essentially a very chaotic system. And while it may be predictable in very short time periods, in many cases there could be surprises. There's all sorts of unknowns.
In next week's program, we look at how the science of weather modification is being developed in order to defend major cities from the growing threat of superstorms.
Today's Premiership highlights coming up in Match of the Day 2 next, and then Graham Norton Uncut with guests including Barbara Windsor at 11:20.
New York. One of the great cultural and financial centers of the world. Home to 8 million people. Few of whom realize the threat they face from a hurricane strike.
It's almost a certainty that New York will get hit by a strong hurricane. And the question is, when is that going to happen?
You can't really imagine the variety of human situations that will occur when a storm like this hits, except to say it will be like nothing the world has ever seen.
It's not just New York that's at risk. As global warming plays havoc with the world's weather, densely populated coastal cities like Shanghai, Tokyo, Hong Kong, and Brisbane will all be increasingly threatened by superstorms. In the light of this, a growing number of scientists now think we should be researching ways to deflect or weaken hurricanes.
We ought to at least look at the possibility that we might be able to reduce vulnerability to serious hurricanes by controlling the storm, by reducing its intensity, by steering it out to sea. We owe it to ourselves to research that possibility.
There is no doubt that a hurricane strike on a major city like New York would create enormous pressure to develop weather modification technology. But how likely is such a strike? And how bad will it be? And could the technology be developed in time to save one of the world's most important cities? Positioned over 1,000 miles north of America's main hurricane belt, New York City would not at first sight seem a likely victim of a hurricane strike.
Hurricanes tend to take fairly typical tracks. Some of them go through the Caribbean and hit Central America. Some go across into the Gulf of Mexico and hit the southeast United States and Florida. And many stay out at sea. They recurve back to the north. New York doesn't appear to be in the traditional hurricane belt, but occasionally you do get a hurricane that impacts the New York area.
Over the last few decades, as the world's oceans have warmed, hurricane behavior has begun to change. And the risk of a rogue storm deviating from the main hurricane belt is increasing.
The heat is coming out of the ocean, adding a tremendous amount of heat to the atmosphere in the form of moisture. The hurricane heat engine converts that heat energy into the mechanical energy of the winds. If we have large increases in hurricane activity, there's a greater probability that a hurricane will hit shore. And I think we're already beginning to see some signals of climate change even in landfalling hurricane statistics.
For New York to get hit, it takes a very specific storm, one that comes close to the southeast United States, and it makes a hard turn and goes due north.
That's exactly what happened in 1938, when a hurricane that was heading straight towards Florida unexpectedly made an abrupt turn.
Of all the signals of the sea, none turns the faces of hardy sailors more grim than the flags that spell hurricane warning. The Coast Guard watched it warily as it moved northward, paralleling the coast.
It was known to be moving northward, but most of the storms would do that curve out to sea. And so the Weather Bureau confidently predicted it would do so.
That night it was off the Carolinas. Next morning it was off Maryland and Delaware, apparently swinging harmlessly out into the Atlantic.
So if you read the New York Times on the morning of September 21st, 1938, up in the upper right-hand corner was a weather forecast. Cloudy with some rain.
What the forecasters didn't realize was that strong southerly winds were sweeping the hurricane northwards. And worse, with such force that the storm was moving 3 times faster than normal.
The recipe for getting a really big hurricane in New England is to have it moving very fast across the water, much faster than ordinary. The 1938 Great New England Hurricane was moving 60 miles per hour when it hit land. Its impact was so terrific that it was registered on seismograms in Alaska.
The Category 3 hurricane slammed into the shoreline at high tide, making its impact all the more powerful.
There was no warning, and when it hit, it just took everybody by surprise.
The 1938 hurricane was one of the most destructive storms ever for New England. However, New York City itself was spared the brunt of that. That hurricane went to the east of New York. So whereas that was a horrible event for New England and 600 people lost their lives, that is not the worst case scenario for New York.
Because the 1938 hurricane made landfall on Long Island, New York City itself had been spared from a direct hit. But New York may not be so lucky next time.
It's almost a certainty that New York will get hit by a strong hurricane. And the question is, when is that going to occur? We don't know for sure, because our direct historical records for New York really only go back to about 1600. And hurricanes for that area are a rare event. So to know how often New York gets hit, we really do need to go back further in time.
Because the historical records are so limited, It's been difficult for scientists to identify any trends that would help them predict when the next hurricane might strike New York. However, Dr. Jeff Donnelly of the Woods Hole Oceanographic Institute has found a way to go beyond the written records using a new science called paleotempestology.
Paleotempestology is the study of past storms. What we're trying to do is extend our knowledge of when these hurricanes hit and help us predict potentially what may happen in the future.
Dr. Donnelly and his team are going back in time by digging down. They are looking for signs left behind by one of the most devastating byproducts of a hurricane: the storm surge. A storm surge is a raised dome of water that's created when the low-pressure center of a hurricane, the eye, pulls water up. This dome of water travels with the hurricane, whose high-speed winds also whip the ocean surface. The result is enormous tsunami-like waves that sweep away everything they encounter. These waves are so large they leave behind clear signs that can be detected through sediment cores.
You can see that this organic layer, which is probably marsh, has sand layers above it, more marsh, sand. And so it's these sand layers that are the hurricane deposits. The storm surge is coming up over the beach and washing this sand into the marsh. So this is like a little time machine.
And the cores paint a chilling picture.
We know, for example, that this is a layer that we've attributed to the 1938 hurricane. This was the 1821 hurricane. It was the last big hurricane to actually pass over New York City. This was the hurricane in 1815. Great colonial hurricane of 1635. And then these storms date to 900 or 800 years ago. And then 1,000 years, 1,500 years.
Dr. Donnelly's research has revealed that over the last 1,000 years, the northeastern seaboard has been repeatedly struck by major hurricanes. Add to this the effects of global warming, and a worrying trend emerges. Not only are hurricanes likely to become fiercer, but water levels all along the East Coast will rise. Within a few decades, New York will be a mere 7 feet above sea level, which means that even relatively modest storms will do as much damage as rare, once-in-a-century storms did before.
So to summarize, basically...
To understand just what this means, the BBC asked Dr. Stephen Baig of the National Hurricane Center to predict what would happen if a major hurricane were to make a direct hit on New York.
Today, but not as wet as today.
Dr. Baig's prediction is based on a powerful computer model called SLOSH.
SLOSH stands for Sea, Lake, and Overland Surges from Hurricanes. It's a numerical model that calculates the amount of storm surge that accompanies the passage of a hurricane over the shoreline. What we're going to look at is a SLOSH hypothetical study of a Cat 4 hurricane making landfall in Manhattan. This is Manhattan, right here. The storm starts to approach, and now we can begin to see the radius of maximum wind approaching, and it's just about to make landfall. Here, the radius of maximum winds has just passed over Manhattan, 8 feet of water there. 6 feet at the airport. The center is now right over Manhattan. 14 feet of water. The maximum storm surge is still building. 22 feet. There's 23 feet. Up to 30 feet if just the wrong kind of storm came along at the wrong speed.
Manhattan's Lower East and West Sides, the financial district, Brooklyn, Queens, the Bronx, Staten Island, all will be inundated by a wall of water. 90% of all hurricane-related deaths are from storm surges, and because of its geography, the people of New York are particularly vulnerable.
Because of the way Long Island and New Jersey meet, hurricanes are funneled into the harbor so that the storm surge, as bad as it is, gets intensified by the topography. And we're looking at the kind of situation that in terms of loss of life, injury, loss of property, is an enormous reality and a potential enormous disaster.
History shows us that the largest loss of life in these events is typically from the storm surge because the water rises quickly, very quickly. And if you're not savvy and you're out in the street or down in a subway or something like that, when this happens, you're going to drown unless you can get to high ground or go up in a building very quickly.
But people who escape the storm surge and take refuge in one of New York's many high-rise buildings will unwittingly face another danger from the hurricane's incredible winds.
If you're in a high-rise building during a hurricane, you want to get off the ground floors in case there's the storm surge, of course. But if you're in the higher levels, you also have the danger of the glass failure.
Just how vulnerable Manhattan's high-rise buildings are to hurricane-force winds was highlighted recently by a team of structural engineers from the University of Western Ontario. They are investigating the impact of extreme wind on building structures, and in particular, on glass.
Jars you, huh? Yeah. There's a lot bigger rim. This is the reenactment of what a hurricane will do to a window. When the wind moves over the surface of a building, it creates pressures. And what we've done in this box here is recreated pressures that we've measured in the wind tunnel and we scaled up to full-scale hurricane conditions. And this device replicates that. And what it is, there's a high-powered fan here. And rather than using the fan to blow wind, we're actually using the fan more like a vacuum cleaner just to suck on the pieces of glass and the different surfaces of the building. And in this way, we replicate the effects of the wind very, very accurately. What we're going to do is look at many different films that we can put on glass to make it stronger or more resilient under the wind loads, to make homes safer for people. And so all of our research is working towards that goal.
Filmed on high-speed camera, it's possible to study in minute detail the forces exerted on glass by the hurricane's winds, and measure the complex stresses and strains that finally cause the glass to blow.
Two things can happen in a hurricane. On a windward-facing wall, the wind's going to push the glass in. You can have the glass entering into the living space, which isn't a good thing. On other parts of the building, actually, the wind wants to pull the glass outwards. And a lot of things can go with it, and so you, again, don't want to sit near windows.
This push and pull effect is most likely to occur in buildings like skyscrapers that have glass windows on all sides. There are hundreds of these skyscrapers in Manhattan, each covered with thousands of windows.
I'm not sure anyone can predict what's going to happen if a major hurricane hit a city like New York. But I wouldn't want to be on street level at all, and I certainly wouldn't want to be in the high-rise area because of all the glass coming down. That would be extremely dangerous. The other problem, if you lose windows, what happens is the wind rushes into the building and it causes the building almost to blow up like a balloon, so you get a greater deal of damage just to that internal pressurization, we call it.
New buildings are made so that they can resist that pressure. But most of the buildings in New York City, in Manhattan especially, aren't built that way. And windows are going to pop when the winds get to 130, 140 miles an hour. That's going to mean glass raining down on the people of the city and blowing through the streets like razor blades. That's one of the things that makes New York both unique and especially difficult to manage when a hurricane actually hits.
Storm surge, channeled to unprecedented heights, and the force of the hurricane winds on hundreds of thousands of windows are a deadly combination for New York City's population of 8 million people.
A 30-foot storm surge will overcome residential and business areas. There'll be bodies floating in 30 feet of water through the most intensely built up sections of New York City. People are going to be unable to leave many of the high-rises. There'll be 25 feet of water at the entrance to the building. They're going to be stuck in their apartments. High winds, flying glass, people getting sucked out of windows if they're not careful. You can't really imagine the variety of human situations that will occur when a storm like this hits, except to say it will be like nothing the world has ever seen.
How ready is the city to deal with a disaster of this scale? Richard Brodsky believes that a hurricane strike on New York could amount to the single biggest catastrophe in US history. And he also believes that the city is in denial over the threat.
In New York City, a hurricane disaster is not a question of if, it's a question of when. And the experts tell us that. But if you ask New Yorkers, well, what happens when a hurricane hits? They look at you like you're crazy. So you're dealing with a population that doesn't believe it's going to happen and doesn't know what to do.
If you say a hurricane's coming in Miami, everybody's terrified, and they know what to do because they've had so much recent experience. In New York, New Yorkers might not think to evacuate or take it seriously.
It's not that the city doesn't have a hurricane evacuation plan. It does. But when he first examined the documents, Richard Brodsky discovered they were deeply flawed.
When we looked at the New York City plan in 2005, the cover sheet was dated August of 2001. The mayor on the cover sheet was listed as Mayor Giuliani, who had been out of office for 4 years, and the companies they were relying on for telephone service hadn't existed for 3 years. No one had looked at the plan since 9/11.
The recent frightening predictions about the impact of global warming on the frequency and ferocity of hurricanes has spurred the city authorities to do something about it. A new evacuation plan has been developed.
I'm confident that we can weather any coastal storms. And on that note,
Michael Bloomberg, the new mayor of New York City, and Joe Bruno, head of New York's Office of Emergency Management, went public with it in 2006.
We've done a lot of work at OEM over these past 10 months or more.
Our plan is brand new. We revised it over the last year, and we're attempting to get the public to understand that when we say you have to go, you go. We have to be ready for it, and we are ready in New York City. Without a doubt, we will handle this for our people.
The plan is now better than it was. Some of the things that were just absurd have been fixed. Others of the things that simply don't work have not been fixed. They're still trying. They don't have the resources. They don't have the political commitment of the community, much less the leadership of the government. The plan that is now in existence can't do the job we need done.
That New York City now has an evacuation plan is a step in the right direction. But the successful evacuation of any major city hinges on a number of critical factors. In particular, time. To get people to safety, you need to be able to warn them when and where the hurricane is going to hit and give them time to go.
Currently, the average forecast track has a fairly big error. Even a day in advance, we often have errors 50 miles or even 100 miles to the left or right. Sometimes we're too fast or too slow as well.
New York City, unlike Miami, faces an added complication. As the 1938 hurricane graphically demonstrated, the further up the east coast a hurricane moves, the faster and more unpredictable it becomes.
It may reach speeds of 40, 50, maybe even 60 miles an hour as it's moving to the north. That does not leave people a lot of time to prepare. So the next hurricane that does threaten New York, we're going to have to issue a wide area of warning, and we're not going to know exactly where it's going to hit in advance or how strong it's going to be.
Experts believe that for New York City, there might only be a few hours of warning before a hurricane strike. This is a forecaster's and an emergency manager's worst nightmare.
If one wants to know precisely where the hurricane's going to go, then you want to look at the very short-term forecast, 12 or 24 hours.
But for New York City's evacuation plan to work, they need at least 3 days warning.
To evacuate, we believe we can evacuate people in 72 hours for a major hurricane.
And it gets worse. Not only will New Yorkers get little warning, they won't know how much to trust the warning. The Office of Emergency Management may have to order the evacuation of America's most densely populated city well before an accurate forecast is available. In other words, they'll be evacuating in case of a hurricane strike, rather than because they are certain there will be one. So will the population, already dubious about the threat, agree to leave?
It's going to be difficult for the public to accept that they have to move out when it's very nice out.
You have these double binds, these almost unsolvable problems. Do you tell them when you're 36 hours out and you could be off by 250 miles? Or do you wait till you're 12 hours out and maybe you can't move them all?
Calling for people to leave their homes to evacuate is a very, very difficult decision to make, not only for the emergency managers, but for the homeowners, the people leaving their house. It's something that you hope would never have to happen to you. And in that process, especially when you evacuate the frail, the elderly, people do die. They're injured just in that process of leaving where they're at. So it's not something you want to undertake lightly.
To order a major evacuation and then discover you were wrong would set a very dangerous precedent for a city that is almost certainly going to be hit by a major landfalling hurricane sometime in the near future. But at the moment, there is no alternative solution. And New York is not the only major city currently facing this dilemma. Shanghai, Hong Kong, Tokyo, and Brisbane all lie in the path of landfalling hurricanes. They are all home to massive populations, and none of them is properly prepared. It's this threat and the lack of alternative measures that are making some scientists seriously consider hurricane modification. And the pressure to act will increase in line with the damage wreaked by superstorms.
We might be able to prevent or reduce vulnerability to serious hurricanes by controlling the storm, by reducing its intensity, by steering it out to sea. I don't think it would take very many years to come up with the technology.
But if we choose to open this particular Pandora's box, the power it could unleash would have to be managed with immense care.
In the computer, we can do some tweaking. We can make it a little warmer, a little colder, make the winds a little stronger or weaker. If theoretically you could do such a tweak, then you could change the course of the hurricane or make it a little weaker. But if you don't get the tweak exactly right, do we know what's going to happen? And I don't think we really do.
I think that the technical barriers are not nearly as large as the social and political barriers, because we rightly don't easily want to tamper with Mother Nature, okay? Even though we do it accidentally all the time. To do it deliberately is a different story.
Highlights of Arsenal v Fulham and the day's top talking points in Match of the Day 2, next on BBC 2, and then Sunday Night Sparkle with Graham Norton, uncut, at 11:15.